interesting concept in Swift in the sense that it has the flexibility that loops in other programming languages probably don't have. And then we're going to be looking at some of this flexibility in this video. Now, in Visual Studio Code, I have this code snippet. Essentially, this is it's creating a multiplication table, and then my multiplier is 7. Now, when you look at this code, I have not specified any type. The type you're seeing here is it was automatically inferred by Swift. So that's one of the we said Swift is a type safe. So the compiler always ensures a type integrity. Anyway, so our multiply is 7, and then this is known as range. So here we are looping with range. It's a closed range. Maybe later on we can look at half open range. So for a closed range, we have begin, start, and end. So here we want to loop. Say for index, say index is integer, in 1 to 12. So this is the closed range. That's beginning and the end. And then inside is a loop body. We have a result, and then for every step of the way, we want to multiply by our multiplier, which is 7. So now we're printing our results. So essentially, this is going to form a multiplication table using 7 as a multiplier. So every step from 1 to 12, we're going to get a result here. So I think I've run it. So this is what we have. 1 times 7 on and on till 12, like so. Okay. Now, there may be cases where we don't care. We don't care about, we don't really actually care about the current count or index number. What I'm trying to say is we could loop with white card, which is an underscore. What I'm trying to say is if we had, for instance, I could do something like this. What can I do here to, okay, no, it's not going to work here because this is a multiplication table, so I'm not going to try to change this. So let's have an instance. Say we have I don't know, maybe we want to sound an alarm 3 times. So we could say 4. So instead of setting a variable name on the fly here, we could have a white card, which is an underscore, name in 1 to 3, like so. And then for every count or for every iteration, we want to do print alert. Let's say battery low, like so. So here we didn't specify the variable that is going to like capture our iteration here. So if I save this, so for every second, we're going to get alert battery low. So let's run this and then let's see what we get. Okay, I think this is building. It's compiling. Okay, so it's done it 3 times. So it's what is it called? It's printed 3 here. So alert battery low. Do we have any more there? Okay. So that's that. We talked about array. We can also look through array. For instance, we could do let playlist, and then we can set this to, okay, so we did song A the other time, song A, song B, and then we could have what is it, song C, like that. And then we could do for song in playlist, playlist, uh, playlist, and then in here we can do, so song is a string, so this is type inference, and then let's say print, here we can say now playing, now playing song, like so. So this is going to print every song in this playlist every step of the way. So let's run this and see. So that's how we can use a for loop to loop through array. We can also do it, say we need both index and the value of the item in our array. So now playing song A, song B, song C. Remember, we say our array is indexed. So this is index 0, index 1, index 2. So we can also loop through like this for, then in here we could have index song in. Now instead of just doing playlist, I don't like that. Let's just do playlist. Instead of just doing playlist, now we can do playlist dot enumerated, say, and then in here we can do print track. So this is going to track our index, and then we could have something like and then the song, like so. So we can also loop by tracking the index of the items in our array, like this. So I'm going to run this, and then this should print the index for us. Okay, so to track 0, song A, track 1, song B, track 2, song C, like so. Another thing we might want to look at is, let's look at some advanced filtering. We could have a where clause. For instance, Swift allows us to attach a where clause directly to a for loop. And then this where clause acts like a gatekeeper. It's keep items that don't match a specific condition without needing an if statement inside the loop. So let's look at how we might accomplish that. We could have let scores, and here we could have some integers. Let's say 85, 86, 75, 90, 58, what is it, 40, 95. I think that's enough. Okay, now we could have something like for score in scores. Okay, we're familiar, so we can say where, so this is a where clause I was talking about, where score is greater than or equals to, let's pick 80, like so. Okay, so in here we could have, so what do we want to print? I want to say print, and then here maybe we do pass with distinction, and then we can do pass here, score here. So this is another, like we said in the beginning of this video, that loops in Swift, Swift is a it's quite an expressive programming language. So loops in Swift is quite what's the word again? Flexible than the loops you might get in some other programming languages that you might be familiar with. So let's run this, then let's see what we get. Okay, so to pass with distinction, so this is featuring just numbers that satisfy these, scores that satisfy this condition. Another thing we might want to do is we want to include break and continue. So this is like control transfer. So this allows us to fine tune our loops, makes it behave dynamically using break and continue. So when we say continue, when we do continue, it stops what we're doing in the current loop iteration and then jump straight to the next item. And then, of course, you should be familiar with break. That stop the entire loop immediately and exit out completely. So let's look at how we might do that. For instance, we could do let phones, and then this is going to be iPhone, Samsung, what else? Techno, Techno, maybe Hightech. What else do we have there? Nokia, Nokia, like so. So this is an array. Then we can do, for instance, we can do for phone in phones, like so. Now inside here we could say if phone is equals to iPhone. If phone is equals to iPhone, then we want to do print skipping no skipping iPhone, skipping hyphen, like so, and then we want to continue. Remember what we said about continue, skips this and moves to the next iteration. So this just jumps to Samsung. This continue jumps to Samsung. We can break out of this if condition, and then we can say if item is equals to maybe this time we want to say item. Okay. No, we can use item. We have phone. Phone is a variable, so phone is equals to item. Then here we can do print item skipping shopping cart. I don't know, shopping cart, and then here we can break. So break, it breaks out of the loop completely, and then here we can do print maybe successfully, and then so let's say this is a shopping cart and then phone. Now you see the flexibility of working with loops. See the inside our folder we're setting all these if condition. We're even using this continue and break clauses to manipulate our data. Okay, so I'm just like gonna save this and then let's see what we get. Okay, so remember, so we started with this, We start with this, and then here we say for phone in phones. If phone is equals to hyphen, we want to print skipping hyphen. So say continue. Remember, we say continue. This we jump to the next iteration. So when it continues, we didn't get iPhone. We just get skipping iPhone. We printed this at this point before continue. So it goes on to the next iteration. So it's a successfully added. What is it called? Phone. Then successfully added Samsung. It goes on to the next iteration. This one, and then the next one successfully added Techno, like so. Now we have another condition here. These extensions, they're getting on my nerves. Then we have if phone equals itel, we want to print this itel skipping shopping cart. So it never got to Nokia because we break out of the loop here. So this is quite interesting. Perhaps what we might even find more interesting is this idea known as pattern matching using part of a tuple. We can implement these in our for loop as well. So let's look at how we might do that. So we could have, for instance, we could have let what I do. Let user. So I'm going to call this. It's going to name. I'm going to set the name to user one, and then password. I'm going to set this to pass123, like so. Good. Now that's for user. I could do let what else alter equals, so this is a tuple, right? And then Swift is automatically inferring the type for us, the type of the data we have inside our tuple. So say name is string, password is string, as it should. Now let's look at author. Should we author? No, let's look at admin, and then here we could have a name. Let's call that admin, and then password. Or we could say admin123, like so. Okay. Another thing we might want to do is let's have another one. Let super admin. No, just do super admin. Let's super admin. Is that working for me? Admin. So this is going to be this a name. Super admin. Okay, so maybe you want the password to be admin123. All right, okay, so maybe we want to do that. We want these two to have the same password, and I'm going to show you why we might want to do that in a minute. Okay, so now we have three tuples, each holding data, name, password. So we can combine these and form an array. So we can do let users equals, so we have an array. Then we can do user, we can do admin, then we can do super admin, like so. So now we have an array. And then Swift is magnanimous enough to automatically infer the data type that we have here. So it says name string password. So it say what we have here, it's an array of tuple. Okay. Now we can loop through this by doing for user in users. Good. User in users. So our user is an array of these tuple that we made here. So maybe we want to get the name or the name in our tuple, the name key in our tuple. If that expression works for this purpose, then we can do print user the name. User the name. I'm going to save this and then let's see what we get. This should create an array of tuples and then give us. Okay, so now we created an array of tuples anyway initially here. So now we are looping through this, and then for each of these tuple, no, this is a tuple. This admin is a tuple. Super admin is another tuple, which comprise the elements of a array here. So we are getting the name property in a tuple. So the first one is user one, admin, and then super admin, like so. That's not all. There are things we can do as well. We can do more than this. We can do, for instance, we can do for case. Look at this. We can do for case, and then we have tuple here. For case, let's say user one, and then pass 1, 2, 3 in users. So this is another thing we can do with a for loop. Then maybe we do print. Then in here, maybe we'd say user has password. Then we pass okay, user has password, pass 1, 2, 3. Well, since we are extracting the values of the properties in our tuple anyway, so this better be here anyway. So I'm going to run this, and then let's see. User has password 1, 2, 3. Okay, so user has password 1, 2, 3. What else might I want to do? Okay, let's leave it at that. We could also do, instead of fetching the value explicit like this, maybe we can track with the for instance, we can do for case, and then in here we can do let name and let password in users, and then in here we can do print username is user and password is password. Oh, this is not working. Password, like so. It's complaining here. What is the issue? It says immutable value name was never used. Oh, I'm sorry. So this should be name. Okay, good. So here we are tracking, we are looping using this case, and then we are passing these two variables here, which represent the name and password in our tuple. And then I'm just going to save this and show you the results instead of telling you in advance. So it's compiling. Okay, so say username is user1 and password is username is admin and password is admin123. Username is super admin and password is admin123. So for each of what we have here, so this is another flexibility that Swift offers us. We might even clean this up a bit. So instead of using let each of the time. You can see for case let, like so, and then this is going to work just fine. I'm just going to change this to super 1 2 3, super 1 2 3, like so. Okay, so I'm going to run this, and then this should work fine just like before. Good. So it works. Now you might think we're not restricted in what we might uh the the flexibility offered to us with Swift for loop. We've been doing for instance, we were looping using the value inside our tuple here, and then we switch to using the key inside our tuple here. We can combine both approaches by, this is what I'm talking about. We could have for case let name, and then instead of password here, okay, so I'm just going to change this back to 1 2 3. This is what I was hoping to demonstrate the other time, why I made the super admin and the admin passwords the same. So for name, for case let name, so that's for a key, not tuple, and then we could have, instead of a password, we could pass the password value admin 1 2 3, like so, and then we could say username is, and then password is obviously password admin 1 2 3. Now for this to print, obviously this has to be true, otherwise it's not going to print. So if this approach works, which I hope it does, then we should see username is, we should get admin and super admin, and then password is admin 1 2 3. Remember, we gave admin and super admin the same password. So I'm going to run this and let's see. Good. See, it's working as we expected. Username is admin, password is admin 1 2 3, and then username is super admin, password is admin 1 2 3. So this works. We talked about dictionaries the other time, so let's look at how we might loop over dictionaries using the key value unpacking task. So I'm going to not everything. Then we could have say we have let stock prices equals what can we do? Let's look at AAPL 175.50. So let's say that's dollar, and then so this is a dictionary, and then maybe Google, and then let's set that to be 150.25, like so, and then I don't know, TSLA, we can set that to be 180.00, like so. So we have a dictionary set up, and then we can use for loop to loop through our dictionary. So for instance, we can do for, and then in here for the key, maybe we do ticker, and then price in stock prices. So this is going to refer to our key, it's going to refer to our value, and then in here we can do print stock stock ticker is currently trading at, so let's look, so the price here, good. uh Something is missing here. Let me include dollar, okay, just to make it more elegant. Okay, so this allows us to look through our dictionary. So I'm going to run this and let's see what we get. Okay, so it says stock TSLA is currently trading at $180. Uh, Go on and on like that. All right. Now recall that when we discussed dictionary, we said dictionaries are unordered collections. Uh, so we can. It turns out that not only can we look through dictionary using a Swift loop, we can order the items in a dictionary as well. So we can use the dot keys property. So for instance, we can do for. So let me just. We can use for ticker. For ticker in stock prices dot keys. Okay, stock prices dot keys, and then we just want to play stock. So what should I print here? I want it to make sense. Maybe I do watching ticker like so. Okay, so let's see what we get. Okay, let's run this. So this is going to order what we have here. Let's see what. Okay, so watching TSLA, APL, Google. What did it do here? Okay, so I think it ordered using our values. So it went from, this is the sending, the the company with the largest stock. So it starts with TSLA, which has stock price of 180, followed by APL 175.50, and then Google here 150.25. So this is quite order in descending. All right. We might also want to look at while loop. Let's look at what we might achieve with while loop. Say we wish to perform a charging device battery task. So let's see what we might do with while loop. So we've been talking about for loop since. Let's try while loop. We could have battery level, and then maybe that's 85%, and then we could say print charging starts. Okay, or something like this. Okay, and then here we can say why. Remember, now we're using var here. You know, we want to mutate this variable, otherwise there's no need doing this. So we're using var here, which is a mutable, so we can mutate this battery level variable. So say y battery level is less than 100. Then what we want to do, we can do battery level Then we can increment, say, by 5. So this increases our charging. And then we can do print print current battery is current battery level is so here we can have a battery level percent like so. Okay, and then otherwise we just do fully charged, print fully charged. So this is how a while loop works. While battery level is less than 100, you can set we can increment here. So I'm going to save this and then let's run it and see what we get. Now, good. Um, Another thing we should look out for while using while loop, and perhaps maybe that's why it's not quite common. When we loop using while loop, if our condition, say the condition here, if it never becomes false, that is, if it's always true, what's going to happen is our app is going to freeze or crash. Yeah, and because where our device is going to run out of memory. So we should always specify a condition that is going to help us break out of our while loop. Otherwise, our while loop is just going to run forever. So I hope that makes sense. So you realize we say while battery level is less than 100, then we want to increment. Okay, so plus we want to increment by 5, and then we want to print battery level. So here, once this well, we can't go beyond 100 here because this is the condition anyway. Says while battery level is less than 100, we want to increment by 5. So once it goes to 100%, you realize we just got fully charged. So this is another thing I want us to be aware of. So this is like a pitfall to watch for. We can also do something like repeat while loop. Say we have a rolling dice game. Let's look at how we might accomplish that. We could have. I'm going to delete this. We could have var dice roll, and then this is going to be int. It's going to be int, okay, and then VS Code. Then we could have our repeat while loop. We could say repeat. And in here we could say dice roll equals integer dot random. No, not random. Then we have in 1 to 6, for instance. So that's going to be in is supposed to be like this. So that's going to be our close range. So we want to repeat using this integer to random method, and then we want to set our range 1 to 6 here, because dice roll has us is a 6 faces now, and then we want to print road a So here we could have a dice roll like so. So we want to repeat for this, and then we could have a y. So we say repeat y dice roll. It's not equals to 6. What do we want to do? So we want to keep rolling if we haven't hit 6 yet. That's what this is doing. So y dice roll is not equals to 6. Maybe we want to print. Then we can print. I thought this approach was going to work. It's not going to work. Then here we can print. Something is wrong here. What am I doing wrong? Dice roll is this. What is this? Int cannot be used as a Boolean test for its a consecutive statement on the line. What is it? This is quite strange. Y dice roll. Repeat. I was quite sure this was going to work. Y dice roll. It's saying, let me see, int cannot be used as okay, I think this is the issue. Good. I'm sorry about that. That's a little typo. So y dice roll is not equals to 6. Then I can do you rolled a say you rolled a 6. You can enter the game. You can enter the game. Something like that. So this we print until we hit 6. That's what this condition is saying. So this loop will repeat for each row 1 to 6, and then for each iteration it checks to see whether our dice roll is not equal to 6. And then when we finally hit 6, we get you roll a 6, you can enter the game. I hope this makes sense. So it will repeat until we get to 6. So I'm going to save this, and then I'm going to run this, and let's see what we get. Good. It says you rolled a 1. It goes on like that. You rolled a 6. So you rolled a 6, you can enter the game. So when we roll 6, we start from 1, and then I hope this is working as I would have expected it to work. I'm not getting any funny result. Because I think Swift is a white space sensitive. Okay. So it's random anyway. Int.random. So it's doing this randomly. So it doesn't. But then the randomness is between 1 to 6. Okay. So okay, I get. Okay. So I'm not mistaken. So then when it hits 6, says you wrote a 6, you can enter the game. So guys, that's all for loops. I hope to see you guys soon.